Okay, this is to help you review for your quiz. So first of all, can you identify why something is not a polynomial function? Let's remember the definition of a polynomial function. It's the sum of terms that all have whole exponents. So this is the exponent. It doesn't matter what you have as a coefficient here. That's okay, as long as the exponent is a whole number like 1, or you could have a constant term because that means x is to the 0 power. So let's look at some of the things that you cannot have. So for example, a right here has a negative exponent. So I can't have any negative exponents. In part B, I can't have any square roots of x. So now I'd like you to go through C, D, E, and F and locate the problem in each. So pause the video and see if you can complete the remaining few problems. All right, so in part C, we have x in the exponent. Remember, our exponents have to be numbers like 1, 2, 3. They can't have a variable in the exponent. Let's see, on part D, these are okay. Someone might say that this is not in standard form. The negative 2x squared should go first, but that doesn't make this not a polynomial. It's this x in the denominator. When you get to higher levels of math, that is a negative exponent, and so we can't have any negative exponents. Okay, in part E, you should have mentioned the fraction exponent. And in part F, it has an absolute value. So you can't have an absolute value either. All right, so now I'm gonna complete part A, and then you should pause it and try B and C on your own. So I can write a polynomial in standard form, state the degree, leading coefficient, constant term, and the number of terms of the polynomial, and I can evaluate polynomial functions for given values of x. So we're going to do that on question 2. So first, to put it in standard form, I put the highest exponent first, so that would be 7x squared plus 2x minus 8. The degree is the highest exponent, so in this case, the degree is 2. The leading coefficient comes in front of the function in standard form, so that would be 7. There are 1, 2, 3 terms. The constant term does not have a variable, so that would be negative 8. If I'm going to evaluate the function at 2, I'm plugging 2 in to either all of the x's in the original one. I like using standard form. So I'm going to plug in 7 times 2 squared plus 2 times 2, and then minus 8. And you could use a calculator, or you could do some math in your head. I'm going to try some math in my head. This is 7 times 4, which is 28. This is 4, and this is minus 8. So if I'm taking 28, this is really a net of minus 4 right here. So 28, and then altogether this is negative 4. My answer would be 24 altogether. So now pause the video while you try examples B and C. All right, so I'm gonna go kind of quickly here. I should have written f of x on this problem, because now this is g of x, right? So g of x, the negative x goes in front, and then the plus 2 comes next. The degree, this is a linear function. X is to the first power, even though it's not written, so the degree is 1. The leading coefficient, even though there's no number here, is really the number negative 1. So when there's no number, it's a 1. There are 1, 2 terms. The constant term is 2. And then g of 2, I'm going to plug the 2 in. It's actually easier to plug it into the original function because it's just 2 minus 2. And 2 minus 2 is 0. Okay, on example C, standard form. h of x equals 3x to the 5th plus 2x squared plus 6. The largest power is 5, so the degree is 5. The leading coefficient is this 3 right here. There are 1, 2, 3 terms total. The constant term is 6. And when I plug in 2, 3 times 2 to the 5th plus 2 times 2 squared plus 6. Let's do this one on a calculator so that we can see how we type it in. Oops. Okay. So I'm going to do 3 times 2 raised to the 5th power. The caret button is right here. Now I have to use the arrow key to arrow over. So that's 3 times 2 to the 5th. I didn't bother to put this parenthesis, but if this was a negative, you definitely want to use parentheses. I'm going to do times 3 times 2 squared to show you what parentheses would have looked like. Oh, this should be a plus right here. I'm adding 3 times, it's actually 2 times 2 squared. So I can actually go back and put a 2. So 2 times 2 squared, and then plus 6. So that comes out to 110. All right. Okay, so now let's see. I can add, subtract, and multiply polynomials. So this says use the polynomials given above. Here was f of x, here was g of x, and here was h of x. And we're going to answer these questions. The first thing I like to do is write down my new equation. I like using standard form since those are already arranged from high to low. So f of x, 7x squared plus 2x minus 8. See how I pulled that from up here? Then I'm adding g of x. If I'm just adding, I don't need parentheses. So I'm going to have negative x plus 2. Now that I have my problem written down, I can just add together my like terms. So I just have 7x squared. I have a 2x and a negative x, so that would be plus x. And then a negative 8 and a positive 2 is minus 6. So 7x squared plus 1x minus 6. On part B, I have a minus sign. So I'm going to set this one up with you, and then you can pause the video and try it. So again, f of x is 7x squared plus 2x minus 8. Oops, and I'm subtracting h of x from up here. 3x to the 5th plus 2x squared plus 6. So this minus sign needs to get distributed to this parenthesis before I combine like terms. So try to distribute it and add your like terms, and then we'll put the answer up in just a minute. Okay. I like to rewrite first. So this 7x squared, this 2x, and this negative 8 are all going to stay the same. Everything after the parenthesis is going to get that minus sign. Unless it already is, if one of these had been negative, I would have made it positive here, but they were all positive, so they all become negative. Let's see, it looks like negative 3x to the 5th is the largest. And then I have a 7 and a negative 2x squared, so that'd be 5x squared. Chink, chink. Let's see, then I've got a 2x plus 2x, and then I've got a negative 14 would be my final answer. All right, so for the last one, we have to add all 3 of these functions together. I don't have a lot of room here, so I'm going to talk through it up top. So if I look at all of these functions, the biggest term I have is that 3x to the 5th. All right, so I've used the 3x to the 5th, and then I have a 2 and a 7x squared, so that would be plus 9x squared. Let's see. It looks like I have a 2x here and a negative x here, so that would be just plus 1x. And then I have constants. I have negative 8, positive 2, and positive 6. So I believe that negative 8 plus 2 plus 6 would add up to 0. So my constant term would be 0. All right, what does expand mean? It just means multiply. So if you have a binomial times a binomial, we know that we can set that up using the box method. And you might say, wait, what about this last x right here? Well, we're going to take care of that at the end. 11 minus 2x and 5 minus 2x. So I'm going to multiply. 5 times 11 is 55. 5 times negative 2x is negative 10x. 11 times negative 2x is negative 22x. Negative 2 times negative 2 is positive 4x squared. But I'm not finished yet. So now I'm going to write that as a trinomial. 4x squared, a negative and another negative. So I'd have negative 32x's all together, and then plus 55. Now I'm going to bring this x into the problem. So I'm going to distribute the x to all three terms. So 4x cubed minus 32x squared plus 55x's would be my final answer. All right, we have done a lot of problems like example 5, so I would definitely pause the video, take this question like it's a quiz question, and then come back and look at the answer. Okay, so it says the equation in number 4 comes from an open top box by cutting out square corners from an 11 by 5 piece of paper and folding up the sides. What is the volume of the box when x equals 1? So they're just wanting you to plug in 1 into this parenthesis. So 11 minus 2, because 2 times 1 is 2, is just 9. And then 5 minus 2, because 2 times 1 is 2. 5 minus 2 is 3. And then times that 1 again. And 9 times 3 is 27. And inch cubed, because this was inches, and now we're talking about volume. It says, is it possible to find the volume of the box when x equals 3? Well, no, it's not. Because one of the sides of our boxes is 5. So I can't cut a 3-inch from one side and a 3-inch from the other side. That would be 6 inches long. So one side is 5 inches, and you can't cut 2 3-inch pieces. Okay, so a reasonable domain, what could x be? X has to be bigger than 0, or there's no box. And if 5 is my biggest side, or my smallest side, 11 I could do bigger. 5 is my smallest side. So the biggest I could chunk out of that would be a 2.5 inch, because then 2.5 would meet in the middle, and I would use up all my paper. So I want to say x has to be smaller than 2.5 inches. All right, number 6, we've done a couple like this. So you may want to pause the video and try it first. This is more of a challenge problem unless I give you the equation. So if you notice in this problem, the farmer has 1,600 feet of fencing to enclose this pasture. This is supposed to be the river, and this is what he's enclosing with his fence. He does not need to fence the side along the river. The farmer writes the following equation: x times 1,600 minus 2x. Explain where the factor 1,600 minus 2x comes from in the equation. Well, the 2x's are coming from here, and the 1,600 is coming from the amount of fencing. So the reason why this is 1,600 minus 2x is because he already has 2 sides of side x and a total of 1,600 feet. So he subtracts 2x from 1,600 to find the other side length. Okay, so if the farmer uses 50, what is the area of this enclosure? So I would have 50 times 1,600. I'm going to do the 2x in my head because 2x would just be 100, right? 2 times 50. All right, so I have to do 50 50 times 1600 minus 100, or just 1500, is 75,000. And we're doing feet squared this time because we're talking about area. All right, what about if the farmer uses 400 feet? Do you think if X is 400, this is going to be better or worse? So go ahead and type in 400 times, I'm doing 2 times 400, so I did minus 800 there, and see what you get. And then see if you can answer what the reasonable domain is for X by yourself. So let's see, 400 times 800 is 320,000 feet squared. So which size pasture? I mean, that is a ton more space for your animals or your food. Okay, the reasonable domain. So we know that X has to be bigger than 0. We only have 1,600 feet of fencing. So my X side can't be bigger than 1,600. For those of you that can think even harder about this, X can't even be 800, right? Because if I laid 800 here and 800 here, I would have nothing left for this side. I need something for this side. So actually a better domain would be that X has to be smaller than 800, but I would accept this answer as well, just because you're seeing that X is smaller than how much fencing there is. So either of those answers would be okay. Okay, so we're on solving application problems involving volume, area, and interest, and stating the domain of the polynomial in an application problem. So what I would do is I would try the last couple problems here. See if you can do it before you look at the answer. I need to add one more bullet point that I forgot to add on the review. I can relate factors to zeros on a polynomial graph. So I need to add that because that was 2, 5 was the zeros. Hank is working for Dunkin' Donuts and receives a $400 sign-on bonus. He decides to invest the full $400 into an interest earning account. R is the annual rate of interest, and at the end of 1 year, the balance in the account is multiplied by a growth factor. So X is 1 plus R. After 1 year, the total value in the account is 400X. If the interest rate is 2%, find the value in the account after 1 year. So remember, X is 1 plus the interest rate. Our interest rate is 2%, and we represent that as the decimal 0.02. So for X, we're going to use 1.02. So I take my 400 and I multiply by 1.02 because it's only for 1 year. 400 times 1.02 is $408 would be after 1 year. Hank does not return to Dunkin' Donuts the next year. Instead, he gets hired by the New Market Basket and receives a $550 sign-on bonus. Hank writes a new expression to represent the value in the account after another year. He writes C of X equals 400X squared plus 550X. Explain what X squared represents in this equation, and then find the value in the account if the interest rate remains 2%. The X squared is representing, X squared is the growth rate for 2 years, right? So times 1.02 and times 1.02 again, because 400 has now been in the account for 2 years. So we're going to do 400 times 1.02 squared plus his 550 times 1.02 for 1 year. So type that into your calculator and see what you get. Maybe pause the video until you get your answer. So I got $977.16. The graph of the polynomial function f of x equals x plus 8, 2x plus 1 has x intercepts at 2 values. What are they? What will make this 0. So when x is equal to -8, we can use the zero product property, and we would have 0 here times, I don't know, what would we have here, -15? 0 times -15 is 0. Now this one is a little bit harder. What will make this factor, 2x plus 1, equal 0? So I'm going to subtract 1 to the other side, and I'm going to divide by 2. So x could also equal -1/2. Those would be my two x-intercepts on the graph. The graph of a polynomial function is given. What are the x-intercepts? Looks like -3, +2, and +5. -3, +2, and +5. What factors must the polynomial function have? We're going to learn that this actually is something special happening, but for now, let's just write down that we know x plus 3 must be a factor, x minus 2 must be a factor, and x minus 5 must be a factor. We're going to learn that x minus 2 is going to be squared because it's bouncing off the x-axis, but right now we're just worried about writing the factors. We're not worried about the multiplicity or the end behavior. This is all we're doing so far. This says a polynomial function has zeros when x equals 2, 0, and -1. Which of the following could be the polynomial? The first thing I want you to look for is I want you to look for an x in front of the factors. So if you notice, this only has the number 5, this has an x out front, and this has an x out front. If 0 is going to be one of the factors, there has to be an x somewhere outside of the factors. So I'm going to eliminate choice A. So now I'm going to think about if I have x plus 2 as a factor, that would have -2 as an x-intercept. But if I have x minus 2 as a factor, that would have +2 as an x-intercept. I want x to be +2. So let's just double check. Yes, this also has -1. So it must be choice C. And for some extra practice, you can complete the practice problems from lessons 4 and 5. So kind of a bonus practice would be page, let's see, 103 to 104, and also 109 to 110.